In the previous video, you learned how to detect GPU device using OpenCL. If you haven't watched it yet, please check it out. Before continuing this video, the link is provided in the description. Today we will see how to compile and run the same C++ code using OpenCL on macOS, Linux and WSL. On the screen, you are currently seeing the source code. This code demonstrates how to detect a GPU device using OpenCL API. For a deeper explanation of the logic and API used, refer to the previous video. In order to run this source code, we will use the clang compiler. To build and run OpenCL C++ program, first open a terminal and check if clang is installed or not. Type a command clang ++ --version. If clang ++ is not found, on macOS run xcode select --, install. This will install clang, clang ++, make, git, ld and other essential developer tool. On Linux, sudo apt-get update, sudo apt-get upgrade, sudo apt-get install clang ++. Once we have installed the compiler, the next step we will install the OpenCL header. If OpenCL header are missing, clone them manually. For that purpose, you can see the link in the screen and also you will see the link in the description. Just clone it. Once we have the headers, let's prepare a source code. Create a new file with the name GPU detection using OpenCL.cpp. Copy the provided source code into this file. Your folder should look like how it's showing on the screen. Your CPP file and OpenCL header, what I recommend, keep in the same directory for easier navigation. At this moment, we have a source code, we have a compiler and we have a header. Let's try to compile the code directly. Then how we compile the code? Clang ++ GPU detection using OpenCL.cpp. Once we will try to run it, we will get error. What error? Fatal error, not found. What does that mean? This means the compiler cannot locate the OpenCL header file cl/cs.h. This header file defines the OpenCL API function. Since it's not a part of standard C++ library, we need to tell the compiler where it is. To fix this, provide the path to the cloned header using -i flag. -i appended with the path tells the preprocessor where to look for the header file during compilation. So our command will become now clang ++ GPU detection using OpenCL -i ./OpenCL headers. Here dot in the front of OpenCL header simply means that we are looking in the current directory. So current directory have OpenCL headers, that's why I have written ./OpenCL headers. You should write the complete path of OpenCL header, what you are providing, where you have cloned OpenCL headers. Oh, one bug fix, raised other bug. Now you will face linker error and that is acceptable. You will see a lot of undefined symbol for architecture. Here clGetInfo refer from main is not defined and we are using OpenCL APIs where we need clGetDeviceInfo and other OpenCL API. What does this error mean? This error indicates that the compiler successfully compiled the code. No syntax error, congrats. But the linker could not find the actual implementation of OpenCL function like clGetDeviceID, clGetDeviceInfo, etc. This happened because we included the header but did not link the program with the OpenCL library or the framework. To resolve this, on macOS we will use the flag -f framework OpenCL, and on Linux we will use -l OpenCL -o OpenCL device. Once compiled and executed, a named OpenCL device will get generated. For Windows WSL, I will recommend follow the same path how it's showing in the Linux. Now, running the program, OpenCL devices will give you output as shown in the screen that you have successfully detected GPU and its capabilities using OpenCL. In next video, we will see how to run on your phone GPU, create an OpenCL context and command queue, etc. Stay tuned for the next part running this code in your phone GPUs.